Hey guys, so I hope you enjoyed that little introduction, but we're going to finish off with solubility, feeding off of lesson 6, so we're picking up with that. A measure of how much solute will dissolve in a certain amount of solvent at a given temperature. That is the actual definition of solubility. Soluble means something will dissolve. That is also known as something being miscible. Okay, not admissible, but miscible. And the more soluble something is, the more concentrated it can be in a solution. It's going to be easier for it to dissolve, so it's going to make something very concentrated. Insoluble means that it will not dissolve. And concentration now, it's a little different than solubility. Concentration is the ratio of the amount of solute per amount of solvent. So it's solute versus solvent and the amount. And it doesn't have to do with temperature. Okay. Dilute would mean that a solution would have a relatively small amount of solute dissolved in a very relatively large amount of solvent. This would be considered a weak solution, and the verb to weaken the concentration of a solution. Now notice I abbreviated, okay? S-O-L-N. When you see I write that, it means solution. Okay, it's just a little easier than writing out the word every time. Okay, so here, dilute equals solute versus lots of solvent. Notice, little amount of solute, lots of solvent. Okay, so let's look at concentrated then. A concentrated solution will have a relatively large amount of solute dissolved in a relatively small amount of solvent. This would be considered a very strong solution. Okay, anything that's concentrated would be strong. Now, when we talk about our calculations, for concentration, when we get to that in lesson 8, we're going to talk about molarity. And that's what we use for concentration of solutions. Now, if you have a 3 molar HCl, this is indicating that you have 3 molar concentration of solution. But if I have a 0.5 molar HCl, this is going to be weak compared to the 3 molar. Okay, so concentrated tells us that we have a lot of solute versus a little bit of solvent. Okay, going on. So most versus least concentrated, and we're going to use table F to help us basically decide whether something is strong or weak. Concentration is directly related to the amount of solute that is dissolved. So on the reagents, you might see something most concentrated you are going to be looking for soluble compounds on table F. Least concentrated, we'll be looking for insoluble. Okay, insoluble compounds. So if a compound doesn't dissolve, it doesn't add to the concentration of the solution. So it's going to be very weak or less concentrated because it would fall to the bottom. It's not dissolved in it. Concentration is related to the amount dissolved. Remember that. So reactions and table F. Using table F to help us what is going to be the precipitate. So here's an example. This could be on the reagents. Silver nitrate and sodium chromate solutions are mixed together. Okay, these are aqueous solutions. If they say solutions, it means aqueous. So they're both in the aqueous phase. They're mixed together. Will a precipitate form? If so, what is the name of the precipitate? So this is going to be a double replacement reaction, and this is what occurs when we have 2 aqueous solutions that we mix together, because you have 2 ionic compounds dissolved in a liquid to create the solution. Okay, so step 1, you're going to write the chemical or word equation for the double replacement reaction. Now you have to go back to naming of compounds in order to help you figure out how to do this. It says silver nitrate, so you have to make sure you have AgNO3, and then of course we're going to have to go in and balance it. So you have AgNO3 plus your sodium chromate and we balance that out by the charges. Chromate has a -2, sodium's a +1, so we crisscross and you get Na2CrO4. And then over here, Ag is a +1, where chromate is a -2, so we had to crisscross that. Notice balancing, okay, you have 2 silvers over here, we had to put a 2 coefficient over here. And then the sodium nitrate. So what's happening? Double replacement. The positive ion in the first product, or reactant, I'm sorry, joins up or combines with the negative ion of the second reactant, okay, and the positive ion of the second reactant combines with the negative ion of the first reactant, okay, and then they switch spots, so it's a double replacement. Step 2, then we're going to check the solubilities for both products on table F. If there are any that are insoluble, then that is going to be a precipitate. Now I'm going to look on my table F, and it tells me that the silver, okay, or anything with a chromate and combined with silver is going to be insoluble, therefore I have a precipitate, or we're using a PPT equals precipitate. Okay, and that's right there. So what you're going to have to do is try some on your own in order to help you figure this out. So will precipitate form when lithium nitrate is mixed with potassium phosphate? Here is the balanced equation, and I look, okay, we're looking at products only, okay? Which one of these is going to be insoluble? Well, we use table F. If you go to table F, notice lithium. Lithium is a group 1 ion, and there are no exceptions for group 1 ions. So this one is soluble. I'm just going to write soluble here to help us, or SOL, okay? So I know. And then I have potassium nitrate. Well, potassium is also a group 1 ion with no exceptions. So this one's soluble. Therefore, there is no precipitate. All right, so for the following reactions, determine the products that are formed, and then we're going to circle any precipitates that are formed as a product. So we're going to have to circle it if it is a precipitate. So let's look. Silver nitrate is AgNO3, and potassium chloride is KCl. Now silver chloride is going to be formed with our double replacement reaction. Okay, the Ag goes with the Cl. The potassium is going to go with the nitrate, so we have potassium nitrate, KNO3. Now, I'm going to look at table F, and you guys need to do this at home. Look at table F. Silver chloride. Chloride is a halide, so your halides, okay, they only have a few exceptions. If they're combined with silver, lead, or mercury, then they're going to be insoluble. So guess what? I don't have to go any further. This is going to be your precipitate because this is insoluble. Potassium, like I said for this one up here, potassium is a group 1 ion, no exceptions. This is going to be soluble. So that is not the precipitate that is formed. Now for number 3, we have copper 2 sulfate. So the formula for that is CuSO4, and sodium hydroxide, NaOH. Okay, to form copper 2 hydroxide, notice how this is going with that. Okay, so copper 2 hydroxide is Cu, and then it's OH2, okay, because that's the 2. The copper 2 comes down on the hydroxide, and sodium sulfate. And to balance that out, it's going to be Na2SO4. All right, now what we need to do is we need to look at our ions, and remember they said look at the back ion first and then go from there. So I know for a fact that sodium is a group 1 metal or group 1 ion, so there's no exceptions here. So this is definitely going to be soluble. So that's not a precipitate. Copper hydroxide. Now hydroxide is the negative ion on the back end. So I go to the second table on table F, or the second, actually it would be the third column I should say. And hydroxide is insoluble, and let's just double check the exceptions. It only says when combined with group 1 ions, calcium, barium, strontium, or ammonium. Well, it's combined with copper. So this does not fall under the exceptions, and it remains insoluble, so that is our precipitate. Okay? Finally, for an exit, I want you to answer these questions and be ready to answer them as your warm-up in class. Number 1, what type of reaction occurs when 2 aqueous solutions are mixed together and a precipitate is formed? Also, number 2, how can you determine if a product that is formed in the above-mentioned reaction is soluble or insoluble, and which product would be the precipitate. How would you determine that? Okay, have fun with that.